So by this point, you're more or less an expert in PyQt5 and can probably build any application that you like. Just to give a demonstration of what you're able to do with the things that you've learned so far, we're going to build a demo application, Mozzarella Ash Badger. Any similarity to web browsers, living or dead, is entirely coincidental. Mozzarella Ash Badger promises a revolution in web browsing. You can go back and forward, you can print, there's tabbed browsing, you can save files, and you can get help. So let's start making it. We start just as we did with our previous application, importing the PyQt5 classes. Here you'll notice we're also importing the Qt WebKit widgets, which are widgets specifically for providing a web browser interface. They provide the actual browser window. So we create our main window subclass. Init super init. We create the window, same as before. We'll set the window title to Mozzarella Ash Badger. And let's run that. There we go. So we've got a window, the window's working. So let's turn that into a web browser. We're creating a widget called Browser. And to do that we use QWebView. Create it. Set the URL using QURL to Google. And then set the central widget. And there we go. We have a web browser. It's literally that easy. If you want some more information about the QWebView class, you can look at the documentation on the qt.io website. Make sure you're looking at the version 5 documentation because there are a few small changes. So now I'm going to set an application icon on the window. Now the icon files are available in the resources for this lesson. I've moved them into a folder called icons. You can set the path however you want depending on where the icon is. I'm using osPathJoin to create the path here, so I've imported that into the namespace. There we go. Now you'll notice it hasn't worked. That's because of a little quirk in Qt that means the window must be visible before you can set the icon on it. So because we don't call show until we're out of the init function, we can't set the icon in the init function. Now the way around this is to move the show that makes the window visible into the init function, and then we can set the icon after it's called. And there we go. We have an icon. This ordering of things in Qt can sometimes bite you in other places as well. It's kind of annoying. You'll get the hang of it. Here I'm just moving the show as far down as possible just to make it keep things nice and neat. So now I'm setting some attributes on the app which are the application name, the organization name, which is just the company that produced the application, and also a domain. Now this isn't the web domain, this is the domain that's used for storing settings. It doesn't really matter what you put in here as long as you're consistent. So that's it. We have a working web browser. We've got a window title, we've got a window icon, and a browser. A good start. So this is the next step in creating Mozzarella Ash Badger, and here we're going to add support for navigation. It's kind of important in a web browser. To do this, we're going to add a toolbar. We're going to call it Navigation. I'm going to add a back button for navigating backwards. I'm not setting an icon yet. We'll need to find them in the Fugue set shortly. Add some helpful text for the status tip. And we're going to add this to the toolbar. And there we go. Back, back, back. So currently we just have the text. It'd be nicer to have a button. To do this, I'm going to go back to the Fugue icon set. I'm going to get a nice couple of icons for back and forward arrows. And I'm also going to get one for cancel or stop. There we go. So let's set the icon. Again, they're in a folder for me called icons and then just the name of the file. So I use ospath join to create that path. That's great. So we've got the icon. Again, we need to set the icon size here because the icons are 16 by 16 and it's expecting them to be slightly bigger. So I'm just going to duplicate the back button and now create a forward button, or next button as I've called it. Just change the arrow around the other direction. There we go, back and forward. Now the buttons don't do anything because I haven't connected the signals. Another key feature of a web browser is an URL bar, so you can type the web address in and see the web address of the current page. So to add this, we're just going to use a QLine Edit widget. And there we go. Back, forward, and the line edit widget, which will be our URL bar. Also going to create a stop button here. which allows us to cancel the navigation. So if we run that, so now we're going to connect the buttons up so they do something. So we're going to connect the signal from the button to the slot on the Q web view. So in this case, we connect to self browser stop. For a full list of the slots available on the Q web view class, you can just look at the documentation. You can see they have them for back, forward, print, reload and stop. So I've connected up all those signals on the other buttons, and I'm now going to add a reload button and connect that up to self browser reload. At this point, we've got a pretty functional browser. The reload works, the browser works, we can reload the page, we can go back. What doesn't work is the URL bar. Now the browser component has an URL changed signal that we can connect to. And we can then forward this to a local function where we update the URL in the URL bar. So the signal passes the new URL, and we can just take that, converting it to a string and setting it onto the URL bar. You'll notice that the URL bar automatically ends up at the end, which is a bit ugly. So what we can do then is just set the cursor location to the beginning of the line at 0, and that then scrolls it back to the left hand side to show you the beginning of the URL like normal. Now, a nice feature would be to be able to see whether we're on a secure or insecure website. We're not going to do this properly, checking certificates and all this sort of stuff. What we're going to do is just look at the URL that we're using to access the page and look whether it's a HTTPS or HTTP URL. So first of all, we're going to have to put the icon on the toolbar to show what it looks like. Now, to add an icon, we're going to use QLabel. It's a bit strange, but QLabel allows you to set a pixmap, which is a image basically, over the entire widget. So we can use that to set our icon into the toolbar. So now we've put our no SSL widget in there, and you can see it on the toolbar. So now what we want to do is to be able to connect to the signal that lets us know that the URL has changed, and there we can check to see whether the URL is a secure or insecure URL. So if we look at what's coming through on that signal, we're actually receiving a QURL. Now QURL contains a attribute called scheme that tells us whether it's a HTTP or HTTPS or FTP or whatever type of URL. So we can just check for that. So if q.scheme equals HTTPS, it's secure. Again, this is not a very good way to check if something is or is not secure. Demonstration purposes only, no liability accepted. So what we're going to do is, depending on that, we're going to set the icon to something else. So here we go, just copy this down, the bit that we've used to set it before. So that's our insecure lock, and then we're going to put our lock that is SSL. So let's run that. Okay, so now it's saying no. I'm going to go to Facebook because that's something that I know is HTTPS. And there you go. It's now changed to the nice secure icon. Backwards and forwards. Awesome. So that's working. Now, at the moment, the URL bar is just showing us what the page is showing, but of course for a normal URL bar you should be able to add an URL, enter an URL in there and have it navigate to that page. So to do that we need to be able to connect to the return pressed signal on the Q line edit. That lets us know when someone's typed something in and hit enter. And that's when we want to navigate. So we're going to connect that to a local function called navigate to URL, and this is going to receive a signal when return is pressed in the URL bar. Now, unfortunately, it does not receive the string, does not receive the content of what's actually in the Q line edit. But since we've stored a reference to the URL bar in self, we can just pull it out of there directly. So we're just going to do QURL self URL bar text to get the text from the URL bar, convert it into a QURL, and then set the URL on the browser. Try that, google.com. Oh no, okay. So you need to do the HTTP at the beginning of it. So that's kind of annoying. So let's just check for that. What we can do is get the text, turn it into a QURL, and then check for a scheme. Again, just like we did before. So you can see when you type the HTTP in there, you get the scheme comes through correctly. When you don't, it comes through blank. So that's cool. All we need to do then is to set the scheme on the URL if there isn't one already set. We're going to set to HTTP by default. So let's just do that again. So when I'm typing google.com, it's replacing it with HTTP and automatically opening that page. Interesting, when I type Facebook, it actually requests Facebook with HTTP, but then Facebook redirects to HTTPS. Okay, finally we're going to add support for navigating home So we can add a home icon to the bar. So that's it. So next for Mozzarella Ash Badger is printing support. Now this is kind of boring, but it's useful to be able to see the support that Qt gives you for printing documents. There's a whole Qt print support library, which makes these things quite straightforward. So let's have a look at that. So we're going to add a printing action. I'm just going to add this to the File menu. So we're going to create a menu bar, a menu called File, and then we're going to add a print action to that menu. Now here I need to set native menu bar to false just because I'm on my Mac and you won't be able to see the menu bar otherwise. We're going to create a local function called print page. So this is a placeholder for the time being just to make sure it looks okay. So there we go, we've got our file, menu and print. And when you click on it, we get the message, printing. So we know the action is working and it's connected up correctly. Now if we look at the public slots in the QWebView class, you'll notice that the print slot actually accepts a QPrinter instance. Now if you go over to the QPrintPreview dialog class, you'll notice that the paint requested signal sends a QPrinter instance. That's not a coincidence. What we can do to get a print preview is just connect these two things up. So we're going to connect the QPrintPreview dialog paint requested signal to the QWebView print slot. What will happen then is that the dialog will send a QPrinter to your QWebView, which will use that printer to print a preview of what the page currently looks like, which then the QPrintPreview dialog can use to display it to us. In practice, this looks like this. Again, there's an underscore after print because it's a reserved word in Python. And there we go. That's it. Pretty easy. You may have noticed that there's a lot of text coming out on the terminal on my setup. This is to do with plugins and various other things in the browser. Don't worry about it. If you see them, you might want to look at it yourself, but I mean, in this case, it's not really important. Now, if you're wondering what you need to do to get from the print preview to actually printing the document, the answer is nothing. Once the print preview dialog is open, if you click the print icon, the document will print. So now the application prints. That's it. We've done it. So finally, let's just smarten things up a bit. We're going to add an icon for the printer so it shows up in the menu. run it, and there we go. Little icon in the menu. Sorted. So the next feature in the whirlwind of amazing things that Mozzarella Ash Badger will be able to do, we're going to add file operations. That's a fancy way of saying opening and saving pages. So again, as is a common theme, PyQt5 offers a few simple, helpful dialog classes that allow you to handle opening and saving files really, really easily. So we're going to create some open file action and a save file action. I've just copied and pasted the open file to the save file. Okay, so we've got two local functions, open file and save file, that we're going to use to handle that. Okay, so let's add the icons again from the Fugue set. So now we're going to add the callbacks for handling this. So we've got the open file and we've got the save file. So again, we're going to create a dialog. Here we're going to use the built-in QFileDialog class getOpenFileName function that is a nice convenience wrapper for providing a file open dialog. So you pass in the window title, the directory to start in, and a list of accepted file types. So out of you get a file name and a parameter which tells you which of your file extensions choices were selected. So that's it. So we can just open the file and set it as HTML on the document. So once we've got the file name from that function, we can then pass it into an open, just as normal with Python. Here I've wrapped it in a context with open file name as f, HTML equals f.read, and then set the browser with the HTML. I've added a stub save file because we need that to be defined because we've referenced it in the action. Just going to run and test the open file. There we go. The file has opened. What would be cool is if when we open a file, the URL bar updates to show the path of the file that we've just opened. So we're just going to do that here. And there we are. Okay, now for the save file. This is basically a copy and paste of the open file function. The difference is rather than get open file name, we now use get save file name. That's the only difference between these two convenience functions. So now we check if we've got the file name, and then we take the HTML from the current browser, self.browser.page.mainframe to HTML. So that's a bit complicated. But self.browser is our QWeb view. Each QWeb view contains a page. Each page has a main frame. This refers to HTML frames, which no one uses anymore, but still the main frame is referred to as main frame. And then to HTML returns that page back as HTML. So then we open a file and we write it. Now, if you're using Python 2.7 as I am, you will need to encode as UTF-8. If you're using Python 3, you'll have to do it slightly differently. For example, so there we have it. Mozzarella Ash Badger now supports file operations. You can now open and save pages as you like. It's common in most applications to have some kind of help dialog or menu where you can get more information about the software that you're running. Now, since we're building a web browser, it probably makes sense to display that information in a browser element. However, it'd also be nice to include a classic about dialog that you'll see in non-web-based applications. So that's what we're going to do. We're going to build a about dialog that gives you some information about Mozzarella Ash Badger. We're also going to put a link in the help menu to bring up some more information. So let's start that. So to start with, we're going to create the menu actions under a help menu we've called help. We've created the menu with menu bar add menu, and now we're going to add a series of actions that can be used to get the help. I just wrote Ash Burger. I'm hungry. So just setting the text as normal. And again. Will someone feed me? Okay, so we're going to connect that to self about. I'm going to add it to the menu. Now we're going to just copy and paste the about action and update it. We can just search and replace the various parts, definitions, and update the text. I'm going to set the callback to self navigate mozzarella. So we're going to just duplicate the navigate home function to create our navigate mozzarella function. Just kind of paste in the Udemy URL. So here we go. Click on the Mozzarella Ash Badger homepage and it opens up the Udemy course that we have here that you're currently taking. So we're going to create the about dialog to begin with, and we do this by subclassing QDialog as before. I'm going to add a QDialog button box to add the buttons to. Here we're just going to add an OK button. We don't need a cancel. Spot deliver error here. We don't actually need to connect the rejected signal. I'm going to add a layout, and we're going to set the layout on the QDialog. And then we're going to start adding some elements. So we just added our button box to begin with. Now we have an about stub here that we're going to add our about dialog and exec it. We're not looking for any return on this, so we don't need to check the output of dialog exec. There we go. So let's extend the dialog a little bit further. I'm going to add a title. Now we want the title to be slightly larger. In Qt, the way to do this is to set the point size on the font. But rather than define a font from scratch, what you can do is get the font of the widget, adjust the point size, and then reset the font on the widget. And there we go, a nice big label. Let's add a logo. We can use a Q label and set the Pixmap to the large logo that we have. Mozzarella Ash Badger logo 128. It's available in the resources for this lecture. And there we go, we've got the logo, Mozzarella Ash Badger. Okay, so let's just add some more text. We're going to add a simple Q label with some made up version numbers. We're not going to adjust the Q label, so we can just pass it straight into add widget as we create it. Good version number, much better than 2335 211 233 231. Awful. Copyright mozzarella. Cheese takes its intellectual property very seriously. There we go. Now, it would be nice if everything was aligned center, so what we can do is just set alignment on these various things using Qt align H center. Because we need to update the alignment on the Q labels, we need to then assign them to variables before we do the alignment on them and then pass them into add widget. So there we go. Beautiful. A little bit of tidying up. Since we want to align all the widgets in the center, what we can do is just get the count of the widgets in the layout using layout.count, iterate over the widgets with item at, and then just set the alignment on it. It's just a little bit neater. So that's it. You have a help menu, an about dialog, and you can click on the link to get some more information. We're done. So this is the final step in creating our application Mozzarella Ash Badger. And what web browser is complete without tabbed browsing? You find tabs in Firefox, Chrome, anything really. And if it's good enough for them, it's good enough for Mozzarella Ash Badger. Now we've already introduced the QTab widget, the widget that allows you to tabify multiple widgets. It gives you a nice set of tabs along the top, and only one of them is visible at any one time. So making tabs out of the browser is actually fairly straightforward in Qt. What's a little more tricky is connecting up the various signals, for example with the URL bar and the navigation buttons, so they correctly affect the correct web view. When we introduced the signals and events, I showed you a few tricks for how to pass additional information along with a signal and redirect signals to particular things using lambda functions from Python. So in this lesson I'm going to demonstrate putting those to use to enable us to tabify Mozzarella Ash Badger without fundamentally changing very much of the internals of the application at all. To get started, we're going to add a tab widget to our application. That's going to hold all our tabs in our application. So I'm going to create a new function called addNewTab, which accepts an URL, QURL parameter, and also a string, which is going to be the label. So we're going to take out the elements that we've got there for creating the web views and create the browser inside the addNewTab function. Now we're not going to store a reference to browser in the self object because we don't actually need it. This will become clear later. So we're going to create the web view, we're going to set the URL just as before, and then we're going to add a tab to the self tabs tab widget. We change the central widget to self tabs. Then we insert an add new tab call, passing in the QURL and the name for that tab as the first and second parameters. So we just run that. We get an error. Main window has no attribute browser. That's because of all the signals that we've got created linked into the browser object. So this is where the lambdas come into effect. Now we've got the tabs widget, and from a tab you can find the current widget using .currentWidget. You call .currentWidget and that returns the widget that's in that current widget position. So using the lambda we can just connect to self tabs current widget back. Same again for this, self tabs current widget forward. It's going to work our way through and replace self.browser with self tabs current widget on navigate home and navigate to URL. And we can just do this in every place that we use self.browser. Because the tab's current widget will always be evaluated at the point where it's in the function, it'll always point to the correct current tab and things will work just as you'd expect. It's a little trickier because here we're trying to connect to the URL change signal for the browser to then update the URL bar. But of course, we only want to update the URL bar if the URL has changed on the current widget. And you can't do self.tabs.currentWidget.URL change connect because that will only be evaluated at this point, which is just when the init function is executed. We'll come back to that in a minute. Now the way around that is to connect to every browser that we create, connect a Lambda function passing in browser, which in this namespace is set to the browser we've just created. Now we can take this value. Now the URL change signal will pass in a QURL, and we take the QURL and the browser and pass this down to our update URL bar function. So now when the URL changes on a browser, the new QURL is passed in together with the browser object that sent the signal. So now in update URL bar, we can just check whether the browser that's been passed in from the Lambda function from the signal is equal to the current widget. What this means is that if the signal is not from the current tab, we can just ignore it and we can just return out of this function. So now, okay, so it runs. Awesome. That's our tab, says at the top, homepage. Tab still works as before. There's no way to create a new tab. So that's kind of it. All the buttons work as before. That's good news. So the next step is to add a function to the file menu to allow us to create a new tab. So we're going to create a new tab action, add it to the file menu. Now we're going to use a Lambda here again because add new tab expects to receive a QURL for the new page to open. Here we're just going to pass in an empty URL and a blank label that says blank. Add the new tab icon to the icons folder. And let's run that. So now we've got the same tab as before, but we have an option on the file menu to create a new tab. And there we go. Notice that the Earl bar hasn't updated. If we type Google, there we go. So that's working. So we've now got two tabs, one that's Facebook, one that's Google. Now here I'm going to set the document mode to true on the tabs, because this makes them look less like a settings dialog and more like a web browser tab. This style is particular to Mac. If you're running on Windows, it'll look completely different. Now the tab widget has a really useful signal that's tab bar double clicked, which is fired whenever someone double clicks in the tab bar area. So now we can take this signal and connect it, tab open double click. When this signal fires, the tab number the double clicking occurred on is passed through. If it happens off a tab in the non-tab area, a -1 is passed through. So we can test for that. So here we go. We can double click in the space and this now adds a new tab. So it'd be quite useful if when you create a new tab, the tab you've created is automatically selected. So we're going to do that now. What would also be useful is for the URL bar to update when the current tab has changed. So there's a tab change signal on the tab widget, so we can just connect to that, get the QURL from the self-tab's current widget URL, and then update the URL bar with that URL. And of course we need to pass in the current widget to confirm that the signal has come from the current widget. So just connect that signal up. So let's run that. So at this point we're getting the main window object has no attribute HTTPS icon. This is because when the URL changes, the icon on the bar to tell us whether it's a HTTP or HTTPS URL is also updated. Now, we've connected and tried to create a new tab before that icon has been added to the toolbar, so of course it's going to cause an error. So if you just move this further down here, then there shouldn't be a problem. There we go. And now when you click the tabs, the URL in the URL bar updates. So it'd be pretty useful if we could close these tabs after we've created them. So you can do this in Qt just by setting the tabs to be closable using set tabs closable. This adds a small little cross on the tab that allows you to close the tab. However, it doesn't work. We need to connect the tab close requested to a function that will close the tab for you. Rather confusingly, I've called this close current tab. However, it's going to close any tab that you request. Here I'm checking to make sure that the number of tabs is at least 2. Otherwise this function will return. We don't want someone to close the last tab. Here you might pop up a dialog box and say, do you want to quit, for example. We just remove the tab that we're referencing by the index that's passed in with the signal, which tab the close request came on. So we'll just open a bunch of tabs. You can click on them and close them. And the last tab won't close. Now at the moment the tab titles all just say blank, except for the first one which says homepage. What would be nice is if once the page is finished loading we could use the title from the page to set the text on the tab. We can do this in a similar way to how we handle the URL change signal. So in the add new tab function we connect to the load finished signal on the browser and connect in to a Lambda function that sets the tab text using the index browser page mainframe title. So you may remember from one of the earlier lessons the Qt web view hierarchy is kind of confusing, but inside the web view, the browser is a page, and inside the page is a mainframe, and here is where title is stored. So we can just run that. Google. Awesome. Let's open Reddit. Always a bad idea. And there we go. It's finished loading.
You may have noticed small bugs crept in here where the Add New tab in the File menu no longer works. That's because I've removed the lambda around the Add New tab callback and the toggled state has been passed through to the function. You can just re-add that now. So that's it. Mozzarella Ash Badger is complete. That's the end of this lesson, but if you feel like continuing to work and add more features, why not add support for multiple windows, copying text from the browser, opening links in new tabs, and bookmarks. That's it for now.